Hi, I'm Joe with Gramophone here in Maryland. Our company has enjoyed a long and strong relationship with Bowers Wilkins, one of the most prestigious manufacturers of loudspeakers on the market. In the summer of 2023, they were kind enough to invite a few of our team members over to England to actually get a private factory tour with Andy Kerr, their Director of Product Marketing. Andy does a great job of presenting just how these amazing loudspeakers are actually manufactured, because B&W does all that manufacture in-house. Their tweeters, drivers, crossover networks, the cabinets themselves. We hope that you enjoy this tour as much as we have. We'll present it in 4 sections. Take it away, Andy.
So this site is the factory that was built in 1999, opened in 2001. The previous building that you were in is our original Worthing-based factory, and that opened in 1972. All those light industrial buildings that you guys drove by between there and here have at various times been part of the Bowers Wilkins factory. Eventually we got to a point where we had so many of them that it was just thoroughly inefficient. There were 10 individual buildings, all small, all interlocking, but it wasn't a great way of working. So we cleared this site, built this building, let all of those other buildings go, but we retained the original one, the first one, because that's where it all started. And at that point, it was converted into what it is now. So that explains hopefully why there are 2 separate sites, also why that one looks pretty small these days. This is our factory. What we produce here is, of course, the Nautilus. The Nautilus is done exclusively by hand. I think, Eric, the last time you were here, we were still in the world of bringing the cabinet in. So it used to be made for us by a company called Race Prep, who used to make racing cars and also did stuff for yachts, that kind of stuff. So they used to fabricate the shell, bring it in, and then we would look after it from there. Since 2.5 years ago, we brought the whole manufacturing in-house. So you literally see the entire process from start to finish on board. Nautilus is wonderful, obviously a great attention getter. It's one of the reasons why we have it in our reception, but let's be equally clear. It's a very, very limited production run product. We're making currently 26 pairs a year. I know you would like more before you tell me, but we're currently making 26 pairs a year and we're working on ways to try and improve that. But we're never, ever going to be in a situation where we're in volume production of that product for a couple of reasons. One, of course, it's very old. 2, because it was never actually engineered in the first place to be something that's easy to mass produce. It was engineered to be the ultimate. If you think of it like a concept car, an automotive show, this is an Italian thoroughbred concept car, right? And taking it and making it is like a week-long work. But we could work just to make the shell, actually, before we even do anything else. 800s, by contrast, is the practical tool that everybody uses, not just audiophiles, but also recording studios. So it's tough, it's resilient. It can be carried around inside recording studios. It looks beautiful. As you obviously saw today in Abbey Road Studios, a lot of them actually wind up being quite a lot damaged and roughed up because they are working tools and they're treated as such. But that means they're built to a completely different specification and a completely different standard of durability, because that is what they are for. We do also produce, and you may well see, CT800. That is an increasingly limited production run product, but it's still around. CT800 was developed essentially as a way of putting performance-oriented 800 series products into a baffle wall enclosure to create something high-end. It's still around. We may see some, we may not, just depends.
This right here is the raw material of the cabinet. Excuse me, there we go. This is a sheet of beech. Now beech, as you can feel, is inherently pretty pliable, right? The reason we use it is it allows us to form the cabinet into the shape we want to form it pretty easily. If you bend one of those pieces of wood in your hands, you can feel it's going to bend pretty easily. That's what happens if you bend too hard, but that's all good. Gives you a sense of how weak or strong it is. Let me give you an example of this. You can feel the wood and the grain orientation allowing you to bend that way, right? Feel that, Kevin? Okay, so if you have that, and I put that in the same grain orientation, bend it again, still quite easy, right? If I rotate that through 90, now try. Yeah, just increase the stiffness straight away. Now, to be clear, that's not rocket science and we didn't invent that. That's plywood. That's how plywood works, right? But fundamentally, you can't bend plywood when it's already done. We buy flat sheet ply, you can see a ton of it right here. You try and bend a sheet of that, A, you're going to require a huge amount of pressure. All right, you're good. It's just the tool. You're going to require a huge amount of pressure, and B, you're more than likely going to crack it. So we are making our own ply for the curvatures of the structures that go into the loudspeaker. For the flat sections that are inside it, the elements that form the matrix bracing system, we just buy it. Because why would you bother to make it when you can buy high grade, right? So this stuff is marine, it's pretty good. It's the kind of thing that we use inside. And this is birch, marine birch ply. This is beech. And we're creating it ourselves in that curved structure. All of the wood that we use these days comes from managed woodlands in Northern Europe. I'd love to be able to say it comes from the UK, but the UK is just way too densely populated. There's only 13% left of the whole UK that's covered by any woodland. And of that, not enough is covered by sustainably sourced wood of this quality. So it comes mostly from places like Germany, Poland, Latvia, Lithuania. Anyway, each sheet of wood is bonded to the next with a sheet of this stuff. This is a white adhesive. It's a glue. It's impregnated with a resin. And when you activate it with heat, the resin releases and the glue pours into the wood. That's the reason why we press hot. You can work with this dry and it's clean. No mess, no fuss, nothing dripping over the floor, nothing on your hands. But the minute you apply heat to it, it activates. And that then bonds one sheet of wood to the next. But like I said, it does require us to press pretty hot. The end game is creating these curved structures. Now that one right here is from one of the smaller speakers. That's an 805. This one right here is from one of the larger ones. That's an 801. We can see as you go forward, you get some pretty substantial layered structures with the alternating grains. Now we have a reason why we have different amounts of material in the cabinet as we scale. The target for stiffness, for strength of the cabinet, is actually the smallest model, the 805. Because small structures are inherently more stiff than larger ones. The larger this loudspeaker becomes, the more likely it is to want to bend and flex in unwanted ways. So we actually have to work harder and use more material to hit the same target for stiffness in the big guy as we do in the little one. Now, the question then becomes, why do I keep going on about stiffness? Ultimately, in a loudspeaker, we don't want you to hear this at all. This is just a vessel. It could be made of any different kind of material. There's a bunch of different reasons why wood works, but equally speaking, as I'm sure you're well aware, lots of different companies have their own approaches for different ways of doing things. The main point is, whatever material you're using, the only thing we want you to hear is the bit that comes from here. This should do nothing. Now, the more stiff we make it, the less likely it is to vibrate. In that regard, this is the complete reverse of something like a guitar. Where in a guitar, you get a contribution effect. You get a beneficial effect from the shape of it. With this, we don't want that. And why don't we want it? Because, as I say, the driving is the king. Now, let's give you a sense of how strong this is. My man, what I want you to do is put a hand here and a hand here, and I want you to push hard. Yeah? Look inside this loudspeaker, and what we've done is we've converted it into a series of smaller sections. You see those slots and grooves that you can see inside? That internal bracing system that's going to go inside that loudspeaker pushes against those side walls and brings back the strength that we lose by having it as an open system, like that. Of course, would you mind holding it like that? The other thing that we've done is we've cut a hole in the front of it. We have to cut a hole in it because we're going to put drive units inside it. So to bring back the strength from that, we use one of those. That's an aluminium plate. We say that a lot, I know. The aluminium plate sits inside, right in there. We're going to glue and bolt that to the inside of the loudspeaker, and that's going to further reinforce it and bring back that strength that we have lost by cutting a hole in the front of the system. Note, we only put it where we need it, right? You don't put an aluminium plate here. Why? There's no hole here, right? You only put it where you weaken the structure. Otherwise, what you wind up doing is just shoving a ton of metalwork into the cabinet, which isn't doing anything. You're adding weight that you don't need to add. The matrix assembly is really important. If you hold the end of the loudspeaker, would you mind just putting your hands on that, real gentle, like that? You feel the vibration now, moving down the wood? Yeah? So basically like this at the moment, this is essentially behaving a bit like a tuning fork. Basically, it's a very stiff, now broken structure, which provides resonance and it will transfer. If you put your hand gently on the end, if I hit that, can you feel the vibration? So what we need to do is control that and deal with it And how we deal with it is by bracing inside it with that matrix bracing assembly. So that turns this long, unbroken stretch of wood that you can see here into a series of smaller individual compartments. Up until 2008, we actually had the cabinets made for us off-site. They were bought into us for a company called Ludvigsen, based in Denmark. They were the people that first specialized in bending wood, creating those bent wood structures. We didn't have the skill set at the time. That's why the older generation 801 was a more traditional mitered wooden joint construction. So Ludvigsen used to make furniture for people like Bow Concepts, that kind of stuff. After 2007, they started to get into financial trouble, essentially because the fashion for curved furniture kind of went away. So we actually bought the wood forming presses and bought them in-house for ourselves. So since 2008, we've been making curved loudspeakers on site here in this building. Now in 2015, we invested in this guy. This is a Cambridge Dynamics K2. It's a very much larger and more powerful press than all of those ones down there. The reason we needed it is because of the new reverse wrap structure, which is much stiffer than the old cabinet structure. This has the power necessary to bend what was then an 800 D3 and now an 801 D4 and an 802 D4 into the correct shape. In fact, it's actually slightly cranked back from its maximum output. We're just pressing at 80 tons vertical, 60 tons horizontal. Now, this has been so successful that we actually are planning to add another one, an even bigger, even more powerful one. It's going to go down in there, past those other three smaller ones. The reason for that is because the increase in demand for the 801 in particular, and now the 801 Signature, means we can't keep up. Because this is currently the only press we've got that can do 801 and 802. So going forward, it means we can have one dedicated to 802 and one dedicated to 801. And that means it's a lot more straightforward. As you can see, the metal plates provide the heat. They're the heat zones. So essentially think of them like a large flat iron. They're heating through the layers of wood, through the layers of glue, impregnating it and activating it. Of course, the power of the tool itself is the thing that's bending it into shape. If you look behind you on the wall, you can see what's called essentially a recipe card. The recipe card, Eric, you might want to capture this, it's useful. It shows the different process for the different models. Right at the top, you can see the 801 is running you at 24 minutes and the 802 also 24 minutes. The smaller loudspeaker has fewer layers of wood. The different tools, different essentially dwell times. This is what it looks like after it's been through the wood forming press. And you can see at the very top right here, there's still what looks to be a bunch of rough edges. But you don't have to machine down very far to get to a fully jointed, fully smooth structure. It's literally a couple inches and you're in, right? This right here is the outer face of any painted loudspeaker. If you take that back one, as you can see, otherwise that will be the surface that you'd be trying to apply paint onto. And as you can imagine, that's less than perfect. It therefore requires more paint, and the chances are you might not get that smooth surface straight away. So the last outer layer that you see in any wrap form is either paper, onto which we then apply paint, and that could be the black, could be the white, or it could be the blue, or a wood veneer. It's bonded in at this stage. To ensure that we don't press marks into it and create damage, what the guys do is they put a clear protective sheet over the top of it. They hit it with an airline, blow off any dust, put that sheet in position, hit it with another airline, and then we start the press. That way it comes out clean. Now this right here is literally the only time you'll ever see anything in this entire factory that's done by eye. Everything else starts to get to millimeter precision or below. There's a reason for this, right? That plate over there is cooking. It's running at 140. We don't want somebody sitting over it trying to exactly line up every sheaf of wood and getting it 100% A1 aligned. We want them to be able to go in there and kind of go and step away, right? So they do this bit by the eye. They literally have a centerline mark and they just do it by eye. And we accept that from this, there will be a degree of offcut, a degree of excess, right? Which is going to be machined away. In this case, you're talking like this, yeah? And all of these excess bits, we will recycle. You see that saddle over there that looks like the foreman's shape? What the guys do in a minute is they'll bring that across, they'll take this on and they'll position it on the saddle. And then they're going to set the next one and just slide it right on in from the saddle. So the saddle will be set at the same height as the tool, and it becomes pretty straightforward. Line it up, start to press. So we've captured all of that. That's going to go through here. You saw the cabinet come out. Some of you guys felt how warm it is as well. What we're going to do now is go to the CNCs and start to see it being machined away. Okay?